All right, I've started the recording. Hi, Christine. Hi, Deepak. Hi, Hank. Hi, Harsh. Hi, Kamal. Hi, Leeladhar. Hi, Rebecca. Hi, Sandeep. Hi, Swarn. Hi, Venkat. All right, I hope you are able to see my screen clearly and hear me clearly. So, before the session starts, do you have any questions to ask? I'll make note of those, and then when we start, we will. I'll try to answer those questions. Yes, we still have 1 more minute. All right. So far, we have understood what does it mean by big data and the general idea about ecosystem. All right. Let me clear up my workspace. Good. All right. No questions. Hey, Kamal. Yeah. All right. So should we start now? Dhiren, we are just getting started. All right. So can we start the session now? Yes. Yeah. I was waiting for others to join. All right. Great. So let's start the session now. Okay. So I think uh, there'll be some more people who will be joining, but that's okay. So we can start now. The session is getting recorded, and we'll do a small recap of whatever we have studied so far. All right. So we started with understanding what does it mean by big data, okay, and why does it matter, and the other platforms as of now that are available for churning humongous data. Then we talked about HDFS. We tried to understand the design of HDFS and how does it help. Okay, how does many computers contribute to a single storage in a powerful way? Okay, then we talked about yarn, understanding the way yet another resource manager, yarn, works, the difference between Hadoop 1.0, Hadoop 2.0, and then one of the paradigms of computing, as in how do I write my code, how do I plan my program, is done using MapReduce. So right now we are discussing MapReduce. MapReduce runs on top of Yarn. Yarn is more like an operating system, which manages the resource of a network. And uh, both MapReduce and Yarn are dependent on HDFS because MapReduce reads data from HDFS and writes output to HDFS. Good. I hope everybody is with me. So yesterday we talked about this scenario when you have too many files, and you want to use MapReduce for converting those files. These files are essentially images and you want to resize them into say 100 by 100 pixels. All right. Imagine this big block here to be the folder. Okay. Is there a sound now, or am I muted or something? I'm not seeing your question. That's why. Great, great. So you can hear. All right. So this big block, you can imagine to be HDFS containing many files. Now this block, what you see here, is running the mapper, and inside it, it's having your piece of code. So you write the code of converting an image to 100 by 100 pixel, and you hand over to Hadoop. Hadoop will take your code, execute that code in the network as I mean, it'll kind of cloning your code and running it on all the node managers inside the container, and then your program is being fed one image at a time from this directory. Who is deciding that one image at a time? That's decided by which input format do you choose, whether to concatenate this all all of these files and feed line by line, or whether to feed one file at a time is decided by the input format you choose. All right. So that is the whole crux of MapReduce. So here there is only mapper, there is no reducer, and when you do not have reducer, the output of mapper directly goes into the HDFS folder. All right. All right. I think I wish I could have shown you this. Maybe on the next session I'll do a demo of exactly this, and I'll try to prepare some 50, 60 images. All right. A question from, yes, very good question. First question is from Jayaprakash. Could you explain this example in case of yarn architecture? Okay, so there is one program called MapReduce. Okay, this MapReduce is kind of a program in itself. Okay, so when let me all right, this is going to be interesting. Okay, let me pick it up. Let me, where is the yesterday one? All right, I think I'll explain. All right, now think of this as, there is a program called MapReduce, which has this logic of this program basically will accept your code, your program. This program is going to pick up your program and then run that program on every node. Correct. So let me draw it. I think a better idea would be to draw it, because this is something I think everybody will find it very useful. And don't worry about the just focusing on one part. Let's say, okay, so you submitted a program of MR. Okay, you submitted a program MR. Okay, so this is your yarn. I'm sorry, again I'm choosing bad colors. I think it'll be better. So this is yarn. All right, so this is your yarn. I mean, not yarn. Let me avoid typing. Okay, so this is your program. Okay, let's call it re. sizer underscore mr dot jar. Okay, this jar is nothing but a zip file containing your mapper logic only and the details inside it. Okay, we will talk about it, how to make it without um, okay, how do you make it without the, so this is your code, this is client for now. All right, and we will talk about it, how to build the code without writing the logic. Okay, now let's think about, yeah, what do you call, resource manager. Okay, RM. All right, and then there are, this guy is a node manager, and there is another node manager. Okay, let's just think about two node managers, otherwise my screen will be crowded. Okay, so it goes to the resource manager and says, hey, what we want is right now, what we want is, okay, so this code is submitted to resource manager, and first thing resource manager does is it, okay, so along with that, there is map reduce client program. Okay, so there is a map reduce dot jar program. Let's just think about it for a minute. So there are two things that you, when you submit your program to resizer, you will ask, you will basically ask, all right, let me try to, you know, do, all right, okay, never mind. Good. So this is what we have right now. So you will give your program to this MapReduce framework. This is your framework. Okay, this is another program. Now this program goes to RM and says, hey, give me my container for my head office. Okay, let's say the container was found in this one. Okay, let's call it application master. This is application master. Okay, so here this will be planted along with here it will contain the mr and your code. Okay, so this container application master will contain mr as well as your code. Okay, now, so you submitted, you gave something to MapReduce library. MapReduce talked to the resource manager. Resource manager talked to, negotiated with both, okay, and gave you gave your MR to be a house. Now this MR MapReduce logic will talk to now this is another communication. So I'm going to, you know, uh, okay, I'm going to make it look like this. So now this MR which we wrote is going to talk to RM and say, can you run my mapper please? Okay, so now in these buckets, these containers, whether on this machine, maybe in this machine, okay, there is going to be your mapper. Okay, there's going to be your mapper. Good. All right. And let's imagine on the other hand, you have, let me try to draw the blocks. I think this will make it clear. There is this lord called name node. Okay, this is name node, and this is data node. This is data node. Okay, so generally these machines will be either, let me also, okay, all right, I think this is a better design. Okay, So what you see is, okay, so all right, now this makes a lot of sense, and I will try to see if I can change the colors more. And good, this is beautiful. Now I'll be able to explain to you. I think this makes a lot of difference. Okay, so this is the only design where you have everything in a single screen. Okay, now I think this makes a lot of sense. All right, so your resizer tells the MapReduce, okay, uh, okay, your resizer, and I'll say plus, okay, location of input and output file. Okay, so you will submit your logic of resizing as a mapper, and also you will submit that this is my the input folder and output folder to the MapReduce. MapReduce will talk to this MapReduce client, will talk to resource manager, and resource manager will first talk to the node managers as well as will talk to the name node. Resource manager will talk to the name node to find out where is the data located. Okay, where is the data located, and figure out which containers or which node managers are near to the data node. All right, so here there could be one file, okay, and let's call it my, this is say, um okay, let's say a1.jpg, a2.jpg is in this. Okay, I mean, these will be data blocks, of course, and uh, all right. Now, see the magic of this part. So these files, basically these are data blocks inside the data node, and all of this information is here, correct? Here, this is where we have kept all these files, and the data is actually here. So this is basically the data, not the files. All right, these are basically data blocks. Now, when resource manager talks to node manager, it will allocate first the head office, meaning the application master containing the logic, what needs to be done, this logic that hey, a mapper need to be run, and once mappers are completed, then we have to sort the data, then we have to do this and other things, though that logic is run inside application master. Okay, and once that is done, so this will, once it gets activated, all of rest of the process is taken care by this one. Okay, the you will only get the access to the logs. Okay, then now these mappers will be running your logic, your code resizer will be run inside this, and here you will be reading the data directly from the data nodes. You'll be reading data from the data nodes and writing back to the data nodes. All right. Okay. So does it make sense to you, Jayaprakash? Everybody? I hope you're not lost in the translation of this thing. S- So what I'm trying to say is that this is my machine one. Okay. This is machine one, and this is machine two. This is machine two. Okay. This is my machine two. Anuja's question is, mapper is containing which logic? Mapper is, you have submitted your mapper. Okay, mapper is right now containing the logic provided by you. Okay, it'll be basically running your resizer. Okay, it'll be running your resizer, because here we are trying to resize each picture, correct? So mapper will be running your logic, which you have supplied here in this bundle. In this bundle you're going to supply the logic of resizing, as well as if reducer is needed, then you will be running this. Okay. Okay, so application master is basically your main method of the program. Application master is containing the main mechanics, saying first run the mapper, collect the data. Once mapper is run, once data is collected, try to merge it, sort it, and then run the reducer. All of that mechanics, all of the map reduce is actually running inside application master. Okay, I hope this is now. Question from Jaipka says that second node manager. Okay, mm, second node manager mapper code will be run. Yes, all of these are containers. Okay, all these oval shaped things are containers. Here, here, here. Because application master is also running in a container. It's like saying that the boss also sits in an office and the employee also sits in office. Similarly, no matter the analogy that we took yesterday, whether it's application master or the mapper or reducer, all of that is run inside the container. Container is your execution unit. Sashi's question is, can we have the sequence number in the flow? Okay, so okay, let me try to okay, let me try to do this. So this is your first, then MapReducer client. This is your client. Okay, this is your client provided by Hadoop. I'm really bad handwriting. Okay. Okay, this is your client. So first step is you write your code. This is the first thing that you do. You write your resizer method like a normal logic, and then you ask mapreduce.jar to do something. Then it'll talk to the resource manager, and then this resource manager will first find out which are the nodes which are nearer to the data, as well as it will send the request to so this is kind of okay, this is kind of 3, and again okay, these are both 4 because they both happen at the same time. And then creating this is this one is fifth step, and then and so on, and this is sixth and sixth, because both the mappers will be executed simultaneously. Make sense? Now, this yellow box is the actual physical machine which contains everything. Okay, because so it is showing that here it shows that there is node manager as well as name node that's running on this machine, and that's the truth. That is the truth about the processes. I'll show you quickly, just that we all remain on the same page. Okay, if you go to CloudX Lab Ambari, there after logging in, let's just pick up any machine. Okay, let's just pick up a machine. I'm going to host. All right, let's take up one of the machines. Okay, this one. All right, so you can see that this is name node. See that? It also has data node. Okay, and it also has node manager. So this way, the way in this box you see name node, sorry, node manager, name node, data node. So in the same way, we have this. All right. So these containers are keep on getting created and deleted inside every node. Japraka's question is, application master will be in a particular node manager where data is present near the, not really. So it could be both. It could be both because it could be, so mappers will be executed nearer to the data. Application master would be executed based on the resource constraints provided by the process. Okay. And generally the application master is kind of not, I mean, it actually depends on the resource request. When the client is talking to resource manager, it can tell that, hey, I need one resource nearer to this data, and that's it. Okay. And actually the chances are, in case of MapReduce, this part is also, application master also talks to the node manager, meaning this also happens. Basically this application master will be talking to the name node, and then accordingly locating the, so you can think of this one as 4.5. So after a resource manager has talked to node managers and created no application master, the application master is talking to name node and finding out where are the files located, and accordingly locating the containers. Now, question from Hank. Also, Spark can do MapReduce. Yes, of course. But that MapReduce will be entirely different. That thing, this client in case of Spark, this client will be different, and hence what runs inside application manager, application master will be entirely different. So the mechanics are entirely different in case of Spark. But the logic of MapReduce is kind of programming way of is kind of a problem solving way of getting things done in the distributed computing world. All right. So MapReduce is kind of a generic way of doing things. So we will see the differences between the two MapReduce. Question from Dhirend. Since the data is replicated thrice by default in HDFS, does any calculation done on one node will also be replicated on another two node? Brilliant question. We are going to talk about it. So this mapper can actually talk to the local disk. Okay, so let's imagine that there is a disk here. Every computer has hard disk, and here also there will be a disk. Okay, and so this mapper, the temporary work of the mapper will be stored in that disk. Okay, so it will not be capped, this temporary work. It is the duty of the application master to ensure how to run a logic, and here it will basically not store the local data in the HDFS. Temporary data will be stored in temporary file in the local file system, while result of a mapper will be pushed to the HDFS. Brilliant question. Thank you, Dhirendra. All right. So this is temporary work. Okay. All right. If container of one machine is full, only then will it be looking for another machine to do the jobs? Not really. So here you are seeing two mapper. Question is bigger. Question from Harsh is that how many mapper would it create by default? Okay, it basically depends on how your data is spread across. If you have 800 machines and all the 800 machines are containing data node, and your file is really huge or your folder is really huge, so that it is spread across all 800 machines, in that case there will be 800 containers running your mapper code parallelly. Okay? All right. Did it make sense to you, Harsh? So number of mappers depend on how many machines contain your data. Okay? The input data. That's why when I say here that I'm providing location of the input, based on this, application master or the resource manager will allocate your containers. Question from Kamal. Oh, sorry, I missed Hank's question. What programming language for mr.jar? That's a very good question, Hank. So there are, one is that you can write in MapReduce, okay, in Java. Second is you can write in Python or any other executable. This mapper can actually execute any binary which can be executed on this computer. All right, any binary, say it can actually execute commands like the usual Unix command, ls, ps, image magic, this, that. So we can use image magic, which is a library, which is a command to convert the file into one form to another. You can get it done using this mapper here. So generally the Hadoop is executed mostly in Unix, either on mainly in on the Linux. All right. Kamal's question is, what temp file is stored on the disk? Say when it's processing the file, it needs to temporarily keep some data locally before giving out to end user. All right. Okay, we will talk about this, the phenomena of temporary files. Dhiren's question is, so there is a replication of MR job on different nodes. So MR job is basically containing many mappers which are running on many machines. Okay, same code is replicated. Question from Sashi is, what if there are any application exception thrown by our code? Where are the logs located? Good question. So Shashi, those are available in uh, as part of the basically, if you look at it here in this diagram, when we said okay, so those are available on individual data nodes, as well as those are available on individual data nodes, as well as you can take a look at those inside the hue. Okay, I'll show you quickly so that we all are on the same page. Okay, and what exactly is my login password? All right, let me just log in. All right, so this is the CloudX Lab. Here we see, all right, so sorry, this is not the one I was looking for. I was looking for this. So that's the console, and we are logging into Hue. So Ambari shows you the admin kind of task, as in what's up, what's down. Although they have come up with the features what Hue also has. With Hue, you can interact with various processes. So you can see in the job browser, you can see all the errors as part of logs. All right. You'll be able to see, not this one. Okay, that has been deleted. Oh, these logs have been deleted. All right. So when we run the jobs, you generally can see the logs here. So maybe we have rotated the logs, so those are removed. Okay. Good. And now moving on. Very, very great set of questions. So I hope we all are on the same page. All right. So on the very simpler note, this is what is going on. On every machine, there are some file on every data nodes, and mapper is being fed those nodes on every parallel in multiple container. The result of the mapper is going in the output. All right. Question from Dhirendra is also, I do remember from previous session that there is a data in that there is a data in masternode and some data is replicated in other two nodes so that primary so that so okay, let me just copy this one. All right. So the question from Dhirendra is that as I do remember from previous sessions that there is data in masternode and some data is replicated to other two nodes that are not primary. So will it run on master node first? So not really. There is no such thing called master. There's no data in the master node. Okay. So if you see this diagram, data is always in the data node. Okay. Data is always in the data node. Okay. Uh, so there are many data nodes. Name node contains only the metadata. All right. So wherever you install data node, okay, nearer to that mapper will be created. A container will be created which will run mappers. All right. Okay. Yes, Hank, just give me some time and I'll explain to you with the example of map resource. I mean the map source code. Okay, so we will try to use some commands today to do the map reduce without actually having to write the data, having to write the Java code. All right, same thing is depicted here on every, I mean, out of the set of files, input splits will be created and mappers will be run against input splits and the result will be, in case there are, okay, map reduce with both mapper and reducer. All right. All right. So let's say you have a job in which you want to aggregate the result of all the mappers. In that case, this will be the flow as we discussed yesterday. Swan's question is it good practice to have name node and data node in a single machine? Generally, it is okay, but if your name node is being overflowed with the request, you can have them different on different machines. Okay. The advantage is that name node consumes lot of RAM, while data node does not consume RAM or CPU. It only consumes the discrete speed, and name node does not consume the discrete. So both are having the complementary need of resources. So it's okay to collocate. It's okay to have name node and data node on the same machine. All right. So this is how I hope this diagram is clear to everyone. So mapper, so earlier there was only mapper. There was no reducer side code because there was no need of grouping various files together or various records together, right? Now we have that need. Let's say we want to sort our data, group our data by city the way we did yesterday. We wanted to group the data based on the city. Correct. So here, mapper will spit out the key and value. Key would be the city and value will be the temperature. And then the data first will be sorted on the individual machine, on both the machine, or on all three machines. Sorting will happen on the keys and then merging of that sorted data will happen on this machine. Correct? Because, and now question from you would be, what's the point of sorting on every node when we have to merge, we have to again sort, correct? Can anybody answer this question? All right. Okay, so Rebecca's point is she's asking for the links for the notes. Let me give you that. Okay, so all right, let me just finish this part first. All right, let me share with you the. Okay, so there was 11 September one. I think 11 September is today. Okay, I'm sending. Ouch! Why can't I copy it? All right, this is today, 11 September, and there will be 10 September. All right, how can I? Just give me a second. I'll just finish this part first. This is yesterday's. All right, good. Now moving on to more questions. All right, so here is the very interesting aspect. Okay, so I'll answer your question, Chintamani, in a minute. All right, question to all of you is, what is the need of sorting the output of mapper, okay, okay, on individual node, okay? We anyway have to merge and sort again. This is a very important question, and interestingly, this is something I was asked when I joined Amazon. Okay, because this is not nothing to do with Hadoop per se. This is to do with this is not only specific to Hadoop, but in general, before Hadoop came into picture, we were doing sorting in the similar way on the cluster. Okay, Sashi says that sorting smaller data sets is faster. Okay, uh, okay, sorting means ordering data and ordering on the basis of key defined by the mapper, because mapper is going to give key, and the objective of the mapper is, all right, to give out the key. The mapper is the one who is defining the criteria for sorting. All right, Brilliant, Christine. Yes. I'm just pasting your points and I'll just see. Okay, good. Very good answers, Jayaprakash, Christine, and Harsh. All right. Correct. Thank you, Saba. Divide and conquer is very easy. All right. Great set of answers. Brilliant. Brilliant. Correct. Correct. That's correct, Haricharan. It's basically like a mud sword. All right. I'm just pasting your answers here. All right. Brilliant. Great. Great. Yes. So basically, the output of mapper is sorted on every machine. On what criteria? The mapper, your code will be giving out key and the value. Key is the criteria for ordering the data. Sorting means ordering the data. Okay. And merging means because the same key could be on different nodes, therefore we need to merge it. Now, a question I was asking is, what's the point of sorting on individual data node when you anyway have to merge it? Let's take a look. Okay, imagine first node is giving 1 to 1, say 3, 18, and 34. See, the data is sorted. Now 2, 4, 6, maybe 18 again, and 34 again, and 35. Correct? if one of the mappers if one of the mappers has given us 1 3 18 34, and other mapper has given us 2 4 6 18 34 and 35, these are the keys. Okay, just for the simplicity, it's very easy to merge them and still having the output to be sorted. And how do we merge them? We basically stand in front of the both the queues. Imagine that this is one queue and this is another queue. During the assembly, the prayer assembly in the school, whereby the shortest kid is standing in front of the queue and the tallest at the end. Similarly, there are two queues having the kids. If you have to merge the two queues, still maintain the and still maintain the increasing order of the heights, it's pretty easy. You just stand in front of the two queues, compare those two who are standing in front, pick the one who is smaller. Okay, then again compare the two, pick the one who is smaller, again compare the two, pick the one who is smaller, again compare the two, pick the one who is smaller. So you can see that it is not too time consuming because you are going to touch all the records only once. Okay, so you can see that, and we are done. All right, so merging sorted data is pretty easy as compared to ordering merging unsorted data and sorting them. Okay, so the work of ordering also has been delegated to many container, one container running this, other container running this, other container running this, and fourth container is running this. Correct? And all of this magic, all of these containers are dancing on the orders of application master, and they're dancing inside node managers. Good. All right, brilliant set of questions. There are two questions that need to be answered, and then we will. Question is, when combiner comes into picture, sometimes you want to reduce the keys on the same node. In that cases, it will can run combiner on every node. Okay, you can run combiner on every node. Also, okay, so combiner is more like reducer, whereby we reduce multiple keys, multiple values for the same key together. All right. So that's the role of a combiner. Good. All right. So basically, this is called what I did just now. This is called basically merge sort, merging, divide and conquer, and then if each part is sorted, then you can easily merge that. All right. Brilliant. Now, moving ahead, same thing I'm trying to depict on the word count, standard word count problem. So let's say you have a text file containing words, okay, and your mapper will be run against every line of this text file. By default, if you give mapper and do not specify the input format, it will consider the input file to be plain text, and every line of the text file is a record that get fed to your mapper function, and your mapper function will get the line. And now this piece of code you will have to write. What does it do? It does not do any word counting. All it does is give out the reason for sorting, give out the key value. That's all this piece of code is doing, and it will basically convert sa re saga into savan revan savan gavan. Now in the next stage in the next stage in the next stage, Hadoop will take the output and order this and group this. Hadoop will take this output, the application master which is running MapReduce will take the result from all the mappers and then group it together. Okay, and then on the reducer node, this aggregation would happen for every key. So there are only three keys. For this one, there is only one value. For this one, ray has occurred only one. Therefore, the numeral one is only one, and so on. Sa is also 1 comma 1. Now, question is why 1? Why not 2? We could put anything here. We just need a placeholder which we can count. Okay, which we can count. And next is that in the reducer phase, all we are trying to do is basically we are counting number of values. That's all, because your reducer is going to get executed against every unique key. Okay, every unique key, and that's all right. So this is the word count, the standard word count problem. Now, this is the diagram which shows the problem that we discussed yesterday, whereby we had these cities and we wanted to compute the max temperature of various cities. All right. So our code basically printed the city, that is the second argument. After splitting by comma, we get city as the second argument. First is the temperature and third is the time. Okay, so we're printing C and T, meaning C is your city and T is your time. This is what we get. And okay, let me make it capitals. All right. And then, okay, all right. So then, so basically you're printing out key and the value. Key is this and value is this. And the output of this is output. This one is being ordered by Hadoop. Okay. Basically, whatever mapper gives out, it will be ordered by using multiple sortings on individual node. And then the result will be gathered like this and then ordered. Okay, then grouped. After ordering after grouping, this is the kind of output you will have. So there are four what do you say, four keys, right? Therefore your reduce method is going to be executed only 4 times, while this method mapper method is going to be executed 1, 2, 3, 4, 5, 6, 7 on each record in the input will be passed through your mapper function. Okay, yes, I'm going to show you hands-on too. All right, so this is enough of theory. In case and same is being shown here again. All right, same is being shown here again. All right, now sometimes you need to have multiple reducers. Why? Okay, so Dhiren's question is, first sorting will happen and then grouping on the mapper. No, only sorting will happen on the mapper. Grouping will happen here. After merging, only then the grouping will happen. Okay, now sometimes what happens is that your one reducer is not sufficient. It's overloaded by too much of work. Wherever there is a singularity, the chances of being overloaded is high. Therefore, what you do is you tell MapReduce that can you please have two reducers, and then it will have two reducers, two nodes running your reducer code. Okay, and then how is it going to happen? Okay, how is it going to manage? It's going to basically send some of the keys to one node, some of the keys to another node. So every mapper node is going to send some portion of the data to both the reducers. Okay, and usual merging would happen. Yes, and grouping will be done on reducer. Okay, good question from Pankaj. Pankaj is saying same key can go to different reducer. No, all the values for the same key will be gathered together, therefore, such that a key is not duplicated. Okay, very good question, Pankaj. And I mean, these the MapReduce ensures that you do not send the same key to multiple reducers. Okay. Question from Christine is, how are you ensured that same keys do not go to the to one reducer? Very good question. Okay. I think Pankaj is also having the same question. A question from Sasi. Merging the reducer's output should also happen. Good question. All right. Now, earlier when we were running, there was no reducer when there was no reducer, the output of mapper was going to directly HDFS. Okay, in case in those cases, if we are churning the plain text file using multiple mappers, then there will be multiple output files. Now, similar question is here. When you have multiple reducers, some keys are going to one reducer, some keys are going to another reducer. Now, now the output of reducer goes to HDFS directly. Therefore, in our word count problem, there would be multiple output files. Okay, question is, how do we merge it? So we basically write separate program to merge the data, and generally we do not need to merge this data. Let it be separate data. Okay, unless explicitly required, because if we can generally manage without merging this data, because next time if we are running MapReducer again, we can essentially run our next phase on a folder, not only on the file. Automatically, when we feed a folder to MapReduce, the records are merged together, and you can basically assume that to be a single file. All right. Now, question from okay, some all right. Another question was, so we generally do not merge the reducer's output. That's the answer. How are we ensured that same keys go to one reducer? Okay. Question is, let's say there was sa here, sa goes to the one reducer, and ray goes to this. This is the job of partitioner. There's a piece of logic here which partitions, which says that, okay, Your name is Sandeep, so you should go to first reducer, and your name is Christine, you should go to the second reducer. That partitioner makes sure, basically, partitioner is the logic that that ensures that one key always goes to one reducer. And how is it done? It computes the hash code. What is hash code? Converting a string or converting a big binary number into a small number. That's called hash code. Okay, so first the string is converted into hash code, then that hash code is divided by number of reducers. If remainder is 0, it goes to the first reducer. If remainder is 1, then it goes to the second. Correct? So that's how the partitioner logic works. Whatever is the key, it computes the hash code of the key and then divides it by the total number of reducers, and then uh, s- if the remainder is 0, it sends the key to the first reducer, and otherwise it sends it to the second reducer. So there are two buckets, one bucket designated for first reducer, second bucket designated for the second reducer. And partitioner basically keeps the data, keeps putting the data into the buckets, and these buckets are getting sorted. All right, brilliant set of questions. I hope I have not missed anybody's question. We discussed this yesterday, that if we have to do the same thing like compute the max temperature, what will we do in case of a select query in SQL? We'll simply say select city, comma max temperature from table group by city. Same thing which we have done using the code. So here also we are not writing the logic to order the data. We're leaving that to the database, right? That's what we typically do. Same thing we are doing in the mapper and reducer. In the mapper, we are writing the code to specify the key, the way we said group by key, group by city. Similarly, we are saying print key, comma, okay? You can say this one is city, this one is city, and let me increase the size, okay? And this one is temperature. All right, all the temperatures given out by maps will be grouped, and then for each city, the array of temperature, this is array, okay? This is array of temperatures, and it's basically uh, our reduce function. The way we are computing max here in the SQL query, the reduce is doing the same thing. Pankaj's question is, so the partitioner is inbuilt functionality of Hadoop, or is it needs to be written in mappers? So by default, partitioning is good. In case, because partitioning is the logic which decides what data goes into the file 1 and what data goes into the file 2. Okay, very good question. I love to answer this. Okay, because these are the genuine doubts which you will never get cleared if you read from the book. Okay, so the question is the partitioning inbuilt functionality of Hadoop, or it needs a logic to be written into the mapper? Okay, so answer is both. All right, by default, Hadoop provides the default partitioner the way I have described to you, based on the hash code. Okay, in case you have better ideas, then you can use the partitioner in your own way. Okay, let us take a look at here. Okay, so if you look at this partitioning, this is partitioning. The keys, the output of the mapper is being divided into two buckets. This is the guy who is creating this division between these two files, part 0 and part 1, right? Some data is going to this, some data is going to this. Let us say, by default, the chances of, okay, I think I'll just cover it a little while later, all right, if you guys do not mind. So for time being, the answer is by default, it is based on the hash code inbuilt you can customize it by by configuring the main method of your MapReduce code. Okay, by while executing MapReduce code, the way you define mapper, you can also define the partitioner. Question from Hank is, who orders the column attributes temperature, city for MapReduce? It does not, because here we are thinking of the input data to be simply line by line. Here we are assuming that the data is plain text, and a single line of that plain text file contains our data, and we are splitting that data based on comma and then printing it out. Okay, so there is no column attributes. Okay, and basically it is the split function which is converting the plain text line into the columns. Question from Jayaprakash says, how can mapper know how many reducers, okay, are present? So mapper does not know how many reducers are present, but partitioner knows. If you are overriding the partitioner behavior, then where are the partitioner knows the place. Partitioner knows how many reducers are there. Okay. Also, inside the mapper, you can actually take a look at the configuration of the MapReduce job and figure out from the current configuration how many mappers, how many reducers are there. Because number of reducers is the prerogative of the person who is writing MapReduce. If you do not specify number of reducers, by default, MapReduce framework is going to assume that you want only one reducer. Okay, by default there is only one reducer. Good. Hank, was I able to answer your question? Jayaprakash, Pankaj? All right. Or did I understand your question correctly, Hank? All right. Next is the okay. Next is similarly the word count also is very much similar to the group by. Okay, is very much similar to the group by. If we have to do the same thing, in case if there is a table that contains two columns, one is word and other column contains just the one. Okay, and then we could simply say select word comma count star from table group by word. That's all right. So similarly we have done here. So grouping is the prerogative of the map side code, and aggregation is the duty of the reducer. All right. But while sorting the data and grouping the data is the duty, the heavyweight lifting is the duty of MapReduce. Okay. Good. Now you have asked me quite a few questions. Now it is my turn. All right. To ask some questions. All right. Quickly. So if you are sitting leisurely, so you have to start paying a little more attention and answer the question. The data generated by the mapper is given to the reducer and then it is sorted and shuffled. Yes or no? Hank and Bernie, can you read the question again? The data generated by the mapper is given directly to reducer and afterwards it is sorted. Is that correct? Or so sorting will be done after the mapper. Okay? Correct. Correct. So yes. So that data is not sorted in the mapper. The output of the mapper, if you look at here, output of the mapper is given is sorted. It's not inside the mapper. Okay. All right. You can say that yes, the same container which is running your mapper code will also sort the data then and there. Okay. In that sense, you're correct. All right. So the output of mapper is first sorted and then given to the reducers. All right, good. Now, second question. The mapper can only generate a single key value pair for an input value. True or false? Mapper can only generate. Hank says multiple. Okay. Venkat Chintamani says false. Okay. 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 So a line, right? If you go back a couple of steps, I'm going back a couple of steps. Here, take a look at this or this. Okay. So individual line is an input to our mapper function. Correct? So how many key value pairs are being generated for per line? One or two? Correct? So now, again, let me ask the question again. The mapper can only generate a single key value pair for input value. Is anybody changing the opinion? So a question to you is, can mapper only generate a, okay, a single key value or it can generate as many it wants to? Input value means the input to the mapper. Right now, in our previous example, here, let's say the input was the whole line. Okay, if we are dealing with the plain text, the input will be a record. Okay, input could be a file, input could be a line. So the answer is false. Correct, Anuja. It can be. So it all depends on the data, but mapper is free to generate as many key value as it wants. All right. Now, the next question is, a mapper always have to generate at least one key value pair. Correct or wrong? Can mapper decide not to give out the data? Can mapper decide that, hey, I don't want to give out a key value. This is a bogus input. Let me just skip. Correct, Christine. If there is no data to split, it can decide not to give out a key value pair. It is up to, let us say, let's take a step back here. Okay, let us say here we want the temperatures to be compared of only the American cities, not the Asian cities. So we might want to put a if condition here. If city is in US, only then print. Okay, so it is up to the map function whether to give out a key or whether not to give out a key. Okay, if file is empty, for example, thank you, Babu. Yes. If the data is bad, that's correct, Dhirendra. Yes. So mapper does not have to generate. It is up to the mapper whether to give one or many or decide not to give out even a single key value. It's up to the mapper and mapper is free to do so. All right. That's wrong. Good. Very good. Very good. Keep going. Yeah. By default, there is one reducer in case of a streaming job. Okay, yes or no? We'll talk about this. I think we are a little too early for this. So yes, for time being, yes, there is only one reducer. Okay, all right, just to check if you are still awake and you are still in the context. In Hadoop 1.0, what was the role of job tracker? Quickly. Yes, correct, correct. So the answer is B. So looks like everybody's awake. Good. The answer is B. All right. Now, okay, so here is another question. The mapper function is executed preferably on the nodes that have required data. Correct. Now, I'll do a little, yes, Deepak. So the mapper logic is always executed preferably, sorry, mapper logic is executed preferably on the nodes that have required data. All right. So this is correct. Yes, it is mapper is executed nearest to the data. Japrakash's question is if there is no data, there is no sense of executing mapper code. Very good question. I think this question requires a good answering. Okay, so who can answer this question? It's a pretty good question. If there is no data, then will the mapper code execute? Yes. All right. So by default, number of mappers is going to be 0 in this case. Correct? Therefore, if you explicitly tell MapReduce job to number of mappers equals to say 10, in that case, you will get the code to be running. And can anybody give me an example of this? One classic example is Scoop. When we are importing data from MySQL. In case of we are importing the data from MySQL, we do not have our local data to process, but we would like to execute our importing logic on hundreds of machines rather than one machine. Therefore, Scoop will essentially execute a MapReduce job where there is no input data on HDFS. Instead, the input data is on MySQL side, and therefore we have to explicitly force that these many mappers need to be executed. Otherwise, it will not run. Okay. Now, so okay, so Leela is asking that can you explain the question and answer? So generally, when we execute our mapper, if you take a look at this one, not this one, here, okay, so our mapper logic is trying to get executed near to the data. Okay, we, we instead of, let's say, running this logic somewhere else on some other machine and then copying this data there and then processing there, it tries to run it near to the data, preferably on the same node. If that's not possible, then on the same Elmira on which same subnet or same Elmira on which the machine is capped, and so on. This is called data locality optimization. Question from Babu is, wouldn't the data from HDFS come to Scoop? Yes, it would. But before starting the process, there wouldn't be any data on HDFS so that we can locate the data node, correct? Because we are importing data here. Therefore, there's no data file and therefore no choice of executing mapper nearer to the data. All right, good. Everybody with me on this? Brilliant. Now, next one is little tricky. It's just rephrasing of the previous one with one big change. The mapper logic is always executed on the nodes that have required data. Always is the keyword. So question is it mandatory to run mapper logic executed on the nodes that have required data? Correct or wrong? Very good. That's your answers are correct. All right. So mapper logic doesn't always have to be on the nodes on which, if this machine on which we were running the trying to run the mapper, which is nearer to the data, it's not available, as well as all the clones of this data located on another network, if those machines are also not free, because every block is copied elsewhere, right? If those machines are also not free, in that case the mapper code will be run on another machine and the data will be transmitted. But that situation is very rare. The chance of getting one machine out of three is very high. Okay, good. Now there are a few more questions. Where does Hadoop store the result of reducer, in HDFS or local file? Quickly. That's correct, Christine. Brilliant. So everybody got it. So yes, it keeps it in the HDFS. Next question is, okay, where does Hadoop store the intermediate data such as output of map tasks, in HDFS, local file system, and or in the memory? Okay, okay. All right, all right, all right. So the answer is a little tricky in this, and I never said that you can only choose one. You can choose more than one, right? All right. So here is the answer. So first, this output goes into the memory, and then from this output of the mapper goes into the memory continuously, and then that memory is parsed out to the local file system. All right. So first in the memory and then to the local file system. So Dhiren's question is, I think Spark puts it into the memory. Spark puts it both in the memory as well as in the local disk. Okay, we will discuss that in detail. All right, brilliant. Moving ahead. All right. So we will discuss these problems maybe later. Now, today we want to do a couple of demo. Yes, Dhiren. So in this case, it is finally on the local file system. Yes, it is not capped in the memory, sorry, forever, and it is not pushed. The temporary data is not kept in the HDFS because it's useless. It's going to anyway get deleted after the MapReduce job is done, and therefore it is not kept in the HDFS. So yes, finally it is in the HDFS. Oh, sorry. Finally, it is in the local file system. All right. So today we are going to do a couple of demos, and all of you have to work with me on this. All right. So before getting, so we will try to avoid the Java MapReduce. In case you are very interested in Java MapReduce, I would recommend you to follow my GitHub repository. Okay. So in case you're inclined to do this, take a look at this sequence of commands. Okay, this is MapReduce example. All you have to do is pull my repository like this. This will do later. Okay, for time being, I'm just keeping it open. All right, good, wonderful. So this was done. Now moving ahead to the second topic today. Okay, second topic is the streaming job. All right. So by default, people started right. By default, you were uh, uh, allowed to. I mean, only you could only write MapReduce in Java. Okay, but then somebody said that. I mean, what if there are people who don't like Java and doing work in Java is little too overhead? You have to create a project, then you have to create all this structure. Can't we just use the commands, the local Unix commands as the mapper and reducer? Can't we do that? So that's where somebody wrote a library. Okay, somebody wrote a MapReduce kind of bridge, okay, which itself is a MapReduce. It takes a command from you for mapper, and it takes a command for you from you for reducer, and you can skip the reducer as well as you can skip the other parts. So it's a Hadoop library which makes it possible to execute any binary or program. When I say binary, means a program as a mapper or reducer or both. Okay, the only constraint is whatever program do you choose, whatever command you choose, it should give out key tab value, key separated by tab and then value. So I'll be honest with you that the first map reduce actually the first big project I did it in Python using Hadoop streaming. My first project was the computation of the recommendation engine. Okay, basically computation of recommendations by cleaning up the logs. Logs cleaning was an important task because all the user behavior is captured by the website, and that website, that behavior is logged in the form of web server logs into the server. Okay, so those files we gathered, we ran MapReduce against those files, okay, using the Hadoop streaming for first cleaning up the data. All right, so that's where I started with streaming, because that's the easiest way to, do the POC, understand whether things are good enough to, uh, I mean, 90% of the work can be done with this kind the Hadoop streaming. It's only those specialized works, actually 99% of the work can be done with Hadoop streaming. Only for the 1% specialized work, you might need Java MapReduce. Okay, all right. So here it is the command. So the mapper, so you can use any command as mapper, any command as reducer, just that your mapper is supposed to give out key and the value separated by tab, because that's how Hadoop is going to understand it. Okay, this wrapper called streaming job, Hadoop streaming job, is going to collect the data from your mapper, or delegate the work to your mapper, and then gather it and form the key value and hand over to the Hadoop. So basically your mapper is supposed to give out key tab value. If mapper gives two tabs, okay, A tab, B tab, C, then, okay, let's say mapper gives A tab, this is a tab, B tab, C. Okay, in that case, these two things will be considered as the value, and this is the key. In case your program just gives out A, there's no tab or anything, key is going to be A, while value is going to be null. Okay, and here key is going to be A and value is going to be B tab C. All right, the output of the mapper is this. Okay, if your command is returning this, all right, now let's take a look at the real command. All right, so let's take a look. So here is my program. What does it do? All right, what does this program do? So here we are saying Hadoop jar. Instead of saying fs, we are saying jar. Jar means I want to run MapReduce program. And instead of providing our MapReduce jar, we are using something called Hadoop streaming. Hadoop streaming is generally located here. In case it is not found here, you can use a command. You can use a command like this: find slash name this. Okay, and to avoid errors coming to your screen, you can send it to the dev null. Okay, if you going to somebody's server and you do not find Hadoop streaming, you can generally use this kind of Unix command to find it. Okay, so this is the default HDP location, Hortonworks Data Platforms MapReduce Libraries location. In case of Cloudera, it could be different. Therefore, you can find it using this. Then you specify where is your input folder in the HDFS. Here, we are saying that our data is in data MR word count input. Do you want to take a look? Let's take a look at this file folder first. So this is going to be our input folder. Let me go to the file browser and then click on edit, and there it is. Big.txt is the file name. Okay, so this is the txt file that we want to do the word count on. Okay, you see this is a plain text file. It's basically the Sherlock Holmes book collected together. All right. Now, okay, Dhirendra, I'll show you how to clean up the bad data, and that we are going to do it together today. All right. Now, sorry. Now going back to my slides. Now, here, this is the output folder that we want to keep. Let me rename this one and say, what's the date today? Or let's say 27 August. Okay, this is the output folder. And please note that while input folder we are keeping at absolute, we are providing the output to be relative. If we provide relative, meaning we are not starting it with slash, that means we want to put the data in our home folder in HDFS. While input folder we are providing, it's not necessary. We could have, these are just two ways of specifying directory. In input, you can also provide a relative location if you put the data in your home folder. Right now, we have put the data at a central location called slash data slash mr. Okay, so this is the now comes, so we have specified input folder. This folder should not exist. Output folder should not exist. Otherwise, MapReduce will give an error. Now we are saying dash mapper. Okay, and then we write something nice here. We are writing SED. SED is substitute. Substitute. Okay, replace space with new line. Here we are saying space with new line and do it globally. We are saying here replace the space with a new line. Do you want to check if it is working? Okay, let's first take this command and understand what does it do. Okay, let me log in into console. Okay, let me take out the console here. Okay, so that it becomes easier to switch between the windows. All right, good. So all right, now let's take a look at Echo. This is Sandeep Giri. This is Echo. Okay, what does Echo do? Whatever you give at the first argument, it is going to print it to you on the screen. Now, instead of printing it to me, I'm sending it to somebody else. And who is that? It is the SED command. And what does it do? I'm saying that substitute space with new line in the input. And who is the input? This line is the input. So you can see that SED has broken down the line into one word per line. Okay, so SED has broken down the input line into one word per line. Sounds good to you? Is everybody with me? So this is the command which basically breaks down any input line given to it into one word per line. Okay, now if, as I said, if the output of your program is only A and there is nothing else, though no tab, then the value is going to be null, and the key is going to be considered the whatever word it is printing. Okay, so SED is a valid mapper which gives out this is Sandeep Giri. These four keys and all the values are null for each of the keys. All right. So any program, we're trying to convert any program into the mapper, correct? So we are going to use SED as the mapper. All right. So SED is the mapper. Now we are saying reducer is unique minus C. What does it do? It basically counts the frequencies in the input. Okay, this is Sandeep Giri and this is someone else. Okay, this is the so this is one sentence is being broken down one word per line. Okay, okay, Anuja's question is what does S do in SED? It's basically a command to SED saying substitute space with new line and do it globally. Okay, do it globally. All right. Globally, as in, even if we avoid, if we do not put G here, it's going to basically only replace the first space, not all of them. All right. Yes. Question from Saba is slash delimiter on mapper command? Not really. This is basically SED format. SED expects the command in this format. The way when you say control F and there are two boxes that separate the text that need to be replaced and the text with which you want to replace, because there are two boxes there. Similarly, these slashes separate the data that need to be substituted and the other string that is substituted. Okay, that's the SED command. All right, is everybody with me on this? Great. So this is the SED command. This sounds a little tricky in the beginning, but as we go forward, you will find that this is so easy to basically get anything done using such kind of command. Now, what does this unique do? Unique command basically basically finds the unique in the input data if input lines are sorted. These are standard Unix commands. If I sort this data, it's going to get ordered in this way, right? And then if I say unique minus C, it's going to give me the frequencies. All right. So unique minus C basically computes the frequencies. All right. Also, please note that in case of Hadoop streaming, the data is not grouped. Okay, the reducer gets ungrouped data. Okay, that's a kind of decision streaming guys did, that they get ungrouped data. Okay, Hadoop streaming gets grouped data, but it ungroups it and then feeds it to the reducer. All right. Yes, Haricharan. So that you are right. So instead of using customized map reducer, right now I'm trying to use the instead of using my own Java code, I'm trying to use the Unix command. Now, word count. What is it that we are trying to do again? We are trying to compute the frequencies of each word. Okay, and how are we going to do? First, we clean the data using SED command, convert line into one word per line, and then using unique minus C, we are going to count the occurrences of every word. Now, unique minus C does not work if okay, unique minus C does not work if our data is not sorted, meaning if I remove sort command. All right, so okay, so let's go step by step. So first there was only echo. Okay, there was only echo, which basically printed this line. Then we fed this data, this whole line, to SED. So the output of echo went to SED. SED broke it down into one word per line by substituting space with new line. Then we sorted this data. You see that? And then we gave to unique minus C. Unique minus C only works on ordered data to find the frequencies of every word. Now, here in case of mapper, we are going to use this and we are going to use this for reducer. The sort command is the duty of Hadoop, and that's how the whole Hadoop streaming is built around. Okay? Now let's try to execute this command and let's see if it is giving the output. All right. You can also try to do it with me. Okay. So now you can see that it says that it has finished the whole work, as well as it has, you know, given us all the statistics. It ran the mapper, it ran the reducer, and saved the result in word count 27 August. Okay, let's take a look at this folder. Okay, I will go to my home directory. All right, I'll go to my home directory and then look for this folder. Okay, let me remove this. Now you see, it contains the output of unique minus C. Unique minus C was our reducer to which all the input was given and handed over. This is the result that is there. Okay, so is everybody able to execute this? Let me check who all are doing. So it has given the word count. Okay, let me check who all are doing. Okay, Kamal is doing. I can see Kamal. Question from Dabral is that can we have multiple keys? Yes. Streaming, Hadoop streaming provides a way to have multiple keys. All right. Pankaj is saying that he's not getting the login prompt. Okay. So can you try in the Chrome if you have Chrome? Are you on the Chrome already, Pankaj? All right. Try refreshing it. Let me try refreshing if I'm also getting logged out. Or if you have SSH, you can use that one. Let me see. Oh, for me, it seems to work. Okay, maybe try resizing your window or try making it full screen. Okay, Harsh is saying, okay, why don't you, if you are on Mac, you can actually do SSH directly to your console. For me, e.cloudxlab. So I can say SSH, and this is my login, e.cloudxlab.com. Okay, all right. For Harsh, it has worked now. Okay, good. So I'm able to log in now. All right, so you could try refreshing, Pankaj. I hope it works. All right, good, good. It worked for all. For Rebecca, also it worked. Okay, good. All right, so I can see what all streaming job that are running right now. Okay. So Christine, you can go to the file browser. There, if you go to this location which you gave in the command, then you can see the data inside that. The output will go into your home folder at this location. Okay. All right. So let me again show you. If you go to the file browser, okay. All right. So and you click on edit and say, and not this. Let me go back here. Okay. So this is where you can see I'm posting this input folder location. So most of our data, the input data, is actually in slash data, as in the data folder at the root level in the HDFS. In the HDFS, you will find all of the data. And then, okay, so inside data, MR, word count, input. And once the process is finished, if you go to the home folder here, okay, you will generally see the output folder once it has finished. Okay, question from Shashi is where seems like my job is stuck. You can just click on the job browser inside Hue and then you will see the status of the job. Ajan's console is also not loading, and somebody was complaining about the putty as well. So in putty, you can basically first find out your login name. Okay, that's available in the CloudX Lab. Similarly, you can find out the console that has been allotted to you. For me, it is allotted as e.cloudxlab. Okay, and and so on. Okay, so you can always. All right. Okay. So Saba is saying that he's getting an Nginx error that it's temporarily unavailable. Which one are we talking when you are going to the console or Hue? When you're clicking on the web console, let me click. It seems to work. Okay. All right. All right. So, okay. All right. Let's take a break for 10 minutes and then try to resolve everybody's problems. Okay. Break for 10 minutes. Back by 10:03 p.m. IST. Thank you, Christine, for the time. All right, so I'm back. Should we start now? There's a question from Harsh. How come in this command unique minus C is working without sort? Okay, all right, all right. Because the sort command, the job of sort is done by Hadoop MapReduce. Okay, because as we told you that the Hadoop will sort the keys, right? And then so that job is done by Hadoop. So the output of your mapper is gathered and then sorted and then grouped and given to your Hadoop streaming. Hadoop streaming ungroup the data and then hand it over to the reduce. All right. A quick question: where did you see all the jobs in Hue? The job browser. Okay, job browser. You could go to the job browser. Okay, here on the right top before the login. Okay, so is anybody stuck right now? I can help you out if you're stuck. Question from Ajan is, where did you see the results? All I did was I went to the file browser. Okay, since in this command I said output equals word count 27 August, which means it's going to be somewhere in this folder. Okay, somewhere in this folder, but since I have too many files, so let me sort it by the date and then I'll see. You can see word count 27 August. Good, Christine. Okay, you're able to run the job successfully. All right. So maybe Ajan, your job has failed. Let me try it. If okay. All right. I think Ajan has also find it. You won't see the output folder in Putty Dhirendra, because output folder would be in HDFS, not on the console. If I go to, let's say, my console, all right, where is my console? Here is my console. If I say ls, and what was the name of the folder that we are looking for? Word count 27 August. Let me see if it is there. Ls word count 27 August. There is no such file or directory. Good. You used, yes, that's correct, Dhirendra. You have to use Hadoop fs minus ls. Brilliant. All right. Correct. Good. Because your output of the MapReduce is saved in HDFS. That's right. Thank you. And okay, a question from Ajan is, why did you say it is sorted without the sort parameter again? So our the SED, okay, gave out the one word per line. That word was the sorting parameter. Okay, so Hadoop sorted that data, and for after sorting the data, it gave to your reduce function. All right, and then rest of the magic happened. So question from Hank. So sorted word count command by Linux command, right? So no. So the sorting was done by Hadoop MR, standard Hadoop MR, not by Unix command. Okay, Unix command SED simply converted the input line into one word per line, meaning the each word became the key, and unique minus C just counted the occurrence of every key. Okay. So Mrityunjay, what's your all right? Let me take a look at. Okay, Dhiren's question is it's a good question. So let me also try to answer this. Mrityunjay's question is the job is running in Uber mode. Okay, let me take a look at which one is your job, Mrityunjay. Probably this one. So I don't know what does it mean by Uber mode. All right, definitely not through Uber taxi. All right, all right, never mind. So going back to the question is how the output is named. How the output is named. I see the default is part 00. If there are more than one file, how will it be named? Okay, good question. So uh, by default, the files are going to be in the form of part 0000 G1. Okay, all right, 1, 2, and so on. Okay, based on if there are three reducers, there will be three files. If there are two reducers, there are going to be two files. Okay, all right, good. In the job browser, how come some jobs take three times as long as the other job? Good question, Azan. So it's trying to execute on the mapper. It may be that it's slightly waiting for other nodes to finish the work. That's why it might take unpredictable time sometimes. Okay. Now, Jayapraka's question is if the input file is already sorted, we can tell Hadoop not to sort. That's correct. So we can ask Hadoop to not sort. All right. If your input given by MR mappers is already sorted, then you don't need to sort that. Okay, there is a flag to stop that sorting. Okay, question from Saba is how do we define to more use more reducers? I'll show you that. Can we override the output file name? You can override the output folder name, but not the output file name. Okay, okay. A question from Ajan. I think some of you also would be facing the same problem. I thought you said in order to use unique, you had to use sort. Correct. So if you saw earlier when I demonstrated, so here if I remove sorting, right? All right, I'll just put hash before that means comment. So you can see that this is the output, and if I pass it to unique command, it did not counted this twice. Unique does not work if data is not sorted, right? This is without Hadoop. This is what we would do ideally using unique in the Unix. So the output of the echo went to SED. SED converted the line into one word per line. Then sorted the data, and then unique computed the unique word. That's correct. Now question is, we are using this command as the mapper, right? We are breaking down every line into one words, and we are only using unique minus c. Then how come in this file, in this command, we did not sort? Why? Because the output of the mapper, the output of SED went to Hadoop. Hadoop sorted the data. Hadoop did the sorting for you. That's what Hadoop does. Hadoop is a mammoth sorting engine. Okay, Hadoop is a mammoth sorting engine. As we discussed earlier, it sorts in groups. So after grouping, it hands over the data to Hadoop streaming. That's the layer, this file, and then Hadoop streaming ungroups the data and hands over to the reducer. Okay, that's a design choice Hadoop streaming did. That's right, Dhiren. We can override the existing. We can basically choose the output folder location. That's all. A question from Christine is, but built into dash mapper function is sorted. Okay, so basically it's a Hadoop's role. All right, I hope you got the answer. So basically, Hadoop's main role is basically sorting data because that's one of the biggest roles. So question from Saba is that you said 99% of the jobs can be done by using Hadoop streaming. That's correct. Most of the work can be done by Hadoop streaming. Here we are using SED. In case of instead of this, we can actually use Python. Okay, any program that can run on these machines can be used as mapper or reducer. Okay, Saba's question is, can you give me example of 1%? The choices where we need to define our own input file formats. Those kind of things cannot be done using Hadoop streaming. Okay. Question from Hank is, what did Yarn do on this job? Yarn is the one who executed everything. Okay, Yarn is the one who executed everything. So you can see if you let me take a look at my own jobs, then you will get some idea. Yarn allocated the container, Yarn took the map reduce job, ran the application master for this, and so on. Okay, so this was the job I had run. Oh, okay. All right. So you can see that the Yarn is the one who created the containers. Okay. It's trying the first attempt. This is the container that got created, and so on. All right. So basically, this whole work is getting done via Yarn. MapReduce is just instructing and asking Yarn for launching the container in which it's running your command mappers and running the reducers. All right. So I'll show you some. Okay. So the actual work is done by Yarn. Actually, the execution, the way we can never say that when we are running this browser, what is the operating system doing? What does Linux doing right now? Mac OS doing right now? All right. All right. Thank you, Mrityunjay, for for a quick update on the Uber jobs. So Uber jobs are everything is run inside the application master without any outside containers in case the data set is small. All right, looks like a question from Babu is, okay, looks like MapReduce does not exactly explain functionality provided by Hadoop. That's right. It does a lot of things. Okay, but that was the easiest way of providing this. All right. Now going ahead, thank you, Mrityunjay. Yes, there are quite a few things Hadoop supports. Christine's question is, why do I get the warning, use this? Yes, they have changed the command, so you can actually launch with Hadoop jar and so on. Same thing with Hadoop jar, yarn jar, and that should be good. Okay, so you can, yes, Shashi, if you go to the console, you can see the time taken by it on the console. When you are running it, you will see how much time it takes. All right, on the console. I've closed my console. When you are running it, you will see at the end of job finishing. Question from Haricharan is, assuming my job fails, why the job is asking for new directory every time? So no, that's a kind of design choice what they made, that the output folder has to be unique. You can delete it as part of workflow. What we do is, as part of workflow, if we are running a job again and again every night, we delete the folder before launching the job. Okay, that's a kind of design choice which they have made. Question from Hank: after sorted and word count, and then what is the next job to do after that? Okay, and all right. There are quite a few. I'll show you some more things. Now, let's go ahead one more step. All right. Let's go ahead one more step. Let's try to understand what was wrong with my code. Okay. Let's try to understand what was wrong in my code and how would you improve it. So this was the result of my code. Okay. Do you find it strange? Do you want to improve it? What are the changes you would like? Okay. Yes, Leeladhar, I'll just show you. Okay. Okay. So you can see that. All right. So it's not cleaned up. That's right. Remove double quotes. Any other suggestions? Remove commas. Okay. Question from Dhirendra is, if job is successful, why is there log in stdr? Okay. So std, that's a default placeholder. Okay. It'll be empty mostly. So you can't do much about it. You don't need to override it. Right. So question from Jayaprakash, we can remove commas. Yes, that's right. We can remove commas, and basically we can remove all these punctuation marks and clean it up. Okay, so let's try to clean it up. And how do you clean it up? I'll try to use my all skills of cell scripting, because that's kind of easier thing to do. And then we'll do the same thing in case of Java MapReduce. All right, these are a little more dense topics. So, all right, so let's try to see. I wrote a command called mycmd.sh. Okay, all right. So what I did was I wrote the multiple commands into a file called mycmd. Okay, I'm going to copy paste it to 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 all of you. Okay, so all I did was, first I said nano mycmd.sh and then wrote the code. Then I saved it as a program. Then I did chmod plus mycmd.sh. Okay, so first I did nano. Okay, then copy pasted the following code, and then I did this. All right, all right. So this is what I'm going to copy paste and so on. All right. So I created a file, mycmd.sh. Then inside that I copy pasted these two lines, right? And then I changed mode to something. Yes, Dhirendra, you can try that. You can write any Python program, and just that you have to say user bin Python in the first line. Good. Everybody okay with this? All right. So now, are you comfortable with this? So I hope this is clear to everyone. This is what we did earlier. Now, in case we are having multiple reducers, we are going to use the other. Okay. All right. Now, question is that we can clean it up further. We can create a file using Nano, copy paste what I have given you, and then your file mycmd.sh should contain the code. Okay. This line should not be in the file. Okay. This first line only from from this line. Okay. Hash exclamation. Now, take a look at this command. Okay. Let's try to dissect this command further. Alright, here we are saying Hadoop jar, or we can say yarn jar, that's also same. Now we will either put back, since the command has to be a single line, we can put backslashes to divide it into multiple lines. Okay, for time being we are going to have only standard things. So input data, input folder remains the same, and this time we are going to call it clean, what's the date? August 27, and mapper is mycmd.sh. This time the command that's going to clean up is mycmd.sh, and then reducer is unique minus c, same one, and file, there is one more argument called mycmd.sh this time. What does it mean? It means that we want to ship this program. Earlier, sed command, unique command exist on all the machines. Both these commands exist on sed, unique, exist on all the machines. But this program called mycmd.sh does not exist on all the machines, or actually doesn't exist anywhere else other than your home folder. Therefore, you have to tell Hadoop that, hey, you have to copy this file in the same folder where you're executing my program. And how you do it? By saying minus file and your program name. So before executing your mapper, it will copy this file on that machine where the container is created. And then the whole process will run. Okay? All right, let's try to see if it works. All right. I'll explain what does this command do, and then we can take a look at the Python program, or we can take a look at the other programs. Yeah. So it is showing you that okay, so it is showing you the times. You can see that. You can see how much time was taken, how many number of bytes were read at every operation, and so on. All right, let's take a look at clean August 27. Okay, where is the hue? Let me go to, I'm just going directly from the URL. Okay, so here it is. This time the data is far more cleaner, right? Data is far more cleaner. You see that? And I can actually, take a look at this program, Hadoop, this output using Hadoop FSCAT. Okay, so you see that? Now I can locally order this data by using sort command. Okay, so you see that the is the most common word, of is second most common, and is third most common, and so on. Okay, so okay, if you take a look at the word frequency, the first word that would strike you is the prince. Okay, then Pierre, and so on. All right, and there is a character called Natasha. So if you take a look at Amazon's Kindle library, there we use these word frequency to figure out the plot and figure out who are the main characters, as well as figure out their entrance, their storyline, that when did Natasha came into the story, and so on. So the prominent characters in a story we generally figure out just based on the word count. Okay, so Babu, most likely you have not executed this command, chmod plus x my command.ch. If this file is not executable, then if you run it locally, so before running MapReduce on the cluster, you should try to run your program locally. Let's try to substitute the previous command. You remember this command? Where was the previous command we were trying? Like this one. Okay, instead of SED, I'm going to use dot dot mycmd dot sh. You can see, you want this one. Okay, all right, so let me put it, to test your command. Okay, you can use this one. All right, and to see what's the output, I have used this command. All right, okay, this is the command we used to see the output. All right, now let's move on. Question from Hank is, can be sorted all characters letter, all char letter? I think you can sort it using n minus k. All right. So Japrika says that I have got a different output. I'll have to take a look at what you got. But I can you just copy paste like couple of lines in the beginning, because I do not have access to your folder right now. I'll have to log in from administrator account. The nr parameter is the sort is a Unix command. Here, this is just for testing. Nr is for the sorting the data numerically and in the reverse order, ascending, descending order instead of ascending. Okay. All right. Yes, that's correct output, Jayaprakash. That's correct output. Okay. If you see, my output is also very similar to yours. Okay. All right. The important part is the okay. All right. But I'm wondering how come you got the different output. All right. Now, all right. So there are a couple of more things I need to answer. One is, what does this my CMD was doing? First, we said instead of replacing only space with new line, we are saying substitute any white space character. White space can be multiple spaces, single spaces, or single tab or multiple tab. That's what we are saying. Space or tab any number of times. Replace the white space with new line. Okay, so that's what we are trying to do. First, whatever is the input line, it cleans it up, as in it converts it into one word per line. Then it replaces, okay, it replaces anything which is not alphanumeric with nothing. Basically, it deletes non-alphanumeric from the line, and then it translates upper caps to lower caps. Okay, Dhiren, looks like you also got the answer. Yes, it's a regular expression. That's why I strongly recommend you that you, because most of the work that happens in the world around is about data cleaning and data churning. So it's very important to learn regular expression. That's why I have created a separate regular expression course that's free for all. So you can take a look at it there. All right. So I hope everybody is with me on this. Yes. Now let's try to do the same thing. Let's try to do the same thing with with two reduced tasks or three reduced tasks. Okay. I'm saying this command, I'm specifying that please run three reduced tasks. And also remember one more thing, you have to change the name of the output file. Okay, you have to change the name of the output folder. Okay, so I'm going to run it again. It says, what does it say? Found one unexpected argument on the command line. Who is the, okay, okay, I got it. There has to be a space. There has to be a space here. All right. All right. There has to be a space. And here we go. All right. This time we are saying that total reduced tasks are three. That means there are going to be three output files. All right. Let me go to my Hue folder. It must have created another folder here. If I sort by the date, I'll be able to see it. Okay. So you can see it has created the folder and there are three files this time. Yes. So three reduced tasks is one. So Saba's question is, will this make a difference in the execution time? When the data is really humongous and reduced task is doing too many things, then this would make a lot of difference. But in our case, the input data is not that big and reduce is not doing too much. Therefore, there it's not going to take too much time. All right. One reducer creates one output file. That's right. Good. All right, so let's try. This was our, you know, in case of my CMD, all right, you could also try. I had written some code in Python. All right, this is my Python code. Actually, all right, this is all Spark, Spark streaming, again, Emma streaming, anagram, interest, to word. Okay, it is to word. Okay, then we have, what is this? Okay, I'll have to take a look at the. I remember that I had done some work earlier. Okay, okay, I don't have a Python example, but a question from Jayaprakash is, on what basis Hadoop will create number of mappers and number of reducers to process data? Number of reducers are specified by you, and number of mappers also can be specified by you. Okay, number of mappers by default are deduced based on number of blocks or the input splits you have. Question from Saba is that which function takes more time, map or reduce on the job? Definitely, if you see this here, total time spent by map, this much, total, or you can see this. Okay, here it is showing that the reduce task is taking the maximum time. Do you see that? So this is how you can find out and compare whether reduce task is taking more time or the map task. Okay, number of mappers is a function of input splits, and generally each input split is equal to, so total number of input splits are generally equal to the number of blocks of a file. Bigger the file, more number of input blocks, and hence more number of mappers. Okay, so if 1000 blocks, the chances are that each block will have one input split, and then for each input split, there is going to be one mapper, and hence probably around 1000 mappers. Okay, so Hank is saying the streaming command failed. All right, did you do chmod there? Chmod plus X. Did your command run independently on the local machine? Okay. Did you test your command this way? All right. So try using this if it's not running, and then it should work. All right. Good. So this was our two attempts on MapReduce. Now the same, instead of writing word this what do you say, mycmd.sh, you could also write mycmd.py. As long as your Python program can run just like this happily, it can be used as a streaming job. Okay, yes, it can be used as streaming job. right, let's try to understand the Java code, and let me just go through a bit of the usual way. So, okay, so again, a quick recap. It's okay to have no reducer. All right, you can remove the reducer part from the mycmd.sh. It will basically save the output as such without doing the word frequency. Okay, you could remove the, if there are no reducer and you do not want sorting, you can explicitly say do not have reduced tasks. Okay, number of maps will, in this case, if there are no reducers, then maps will decide the number of output files. Okay, number of maps is a function of input splits, which is generally a function of input split block and input format. Okay, you can configure that. You can specify number of mappers as well from the console. Now question is, how many number of reduces? This is a common question that people ask. Okay, how many number of reduces? The quick answer is somewhere between 0.95 to 1.75 times the maximum possible task. And how much is maximum possible task? Number of nodes multiplied by maximum reduced task. Simultaneously, max. Okay, so let's. I mean, if you go here and say dashboard, there, if you go into MapReduce, all right, and here. So here it shows you that how many containers can be created on a node. All right. So you can see that it is a function of the size. So total size which we have dedicated to container is this much, divided by the size of the memory, and that's what is the uh, maximum containers that can be, maximum tasks that can be executed on the cluster. Okay, so total tasks that can be executed on the cluster, your number of reduces should be somewhere between 0.95 to 1.75 times. It's an arbitrary number. Okay, but general thumb rule of figuring out how many reduced tasks you want is to pay clean attention, pay very very you know pay pay great attention to this. Okay, to this part, specifically this part. Okay, not this. Total time, yeah, these two numbers, pay attention to this. Okay, so when you increase reduce task, the first the time taken, the time consumed in reduced task will decrease, and then it will start increasing. That means initially when you're increasing reduced task, it's actually helping you, because if reduced task is really overloaded, when you increase the number of reduced tasks, it will, this total time consumed during reduce will decrease, and then okay, and then uh, that's how you judge it. All right, so basically you observe how much time it's taking, and generally if you suspect that reduce is taking too much time, you increase the number of reducers and so on. A question from Jayaprakash: where can we find the number of reducers and mappers used in the particular job? You can actually take a look at the log. There you should be able to see how many mappers and reducers were used. In the logs, it prints that. All right. Shashi's question is, what is ideal map to reduce ratio? There is no such thing. Okay, there's no such thing as ideal map to reduce ratio. It all depends on the kind of workload. If you are doing the character count, there is not too much of workload in the reducer.
in case of word count there would be. In case you're processing, let's say, image, the way we were resizing, that there is no, not at all any work for the reducer. So there is no standard prescription for number of mappers to reducers. Okay. Another question is, this configuration are done admin persons or developers? So admins by default define things, but number of reducers and number of mappers are defined by the developer. If you do not specify number of mappers, it will be equal to the number of input splits or number of input formats input blocks. Okay. If you do not specify number of reducers, by default is going to be one. So Dhiren's general question is, generally more reducers and less time of processor on the reduce side, right? So if you increase a number of reducers, it will reduce the total time consumed on the in the reduce phase. But if your data is small and you increase reducers, it will keep on increasing the framework load. Okay, there'll be more shuffling. All right. For testing a map reduce job, first test on small data, generally a random sample, and separately test mapper and reducer. Streaming job can be easily tested this way. Cat input file, mapper, or you can say, in case your data is in HDFS, you could say, okay, Hadoop fs minus cat, and you could say head means just take 10 lines from the file and then pass it to the mapper and the sort, and then so on. Okay. So this is also, you can try, this is something you can try. Basically we are trying to, instead of cat input file, meaning take the file, print it to my mapper, this is your mapper command, and then run the sort. This is how you generally test a streaming job without Hadoop, and so on. Okay. In case you are doing testing predictions, is a general thumb rule from statistics. So split the data in two parts, chronological 80 and 20, generate the predictions on the first set, and then compare the predictions against the second set. Right? That's how you generally do the map reduce. Okay. Everybody with me so far on this? All right. Okay, so before we take a break, I would like to take you through my repository. Is everybody with me? So let's open this piece of code. Okay, so here is my code for Java. All right. So this code contains my MapReduce program. Build.xml decides how to compile the code. So it is saying that, okay, build such and such output folder. This is so this build.xml defines how to compile and bundle the code. Instead of we manually doing it, build.xml will compile. So I have written build.xml for my program. Readme.md is this readme file which provides the steps to do. Okay, then there is, so build.xml says that when your src will be compiled, it will put the data into build. Okay, so src contains the main code. Okay, we are not going to touch hive udf, neither we are going to touch this, we are going to see this one. Okay, so while we write the mapper reducer in Java, okay, so we are going to create three main files. One is mapper, okay, mapper, reducer, and driver. Okay, so mapper looks like this. It basically extend a parent class, and then we define the map function. Okay, and here is the logic. We're trying to say take a line, take the line, split it by space or tab, and then clean it up, and then print the print the key and value. All right. So and then in the reducer we are not doing much. We are basically getting key and list of values. This is list of values, and we are iterating over the list of values and summing it up and giving out key and the sum. All right, that's all we are trying to do here. All right, let me try to execute this for you. All right, and step driver I have not discussed. So we defined stub mapper, we defined a mapper, and we defined a reducer. The format, you can take a look at it, it's not too much of a difference. Okay, so in the driver we tie the things together. This is the entry point where we create the config object first, then the job. Okay, then we set the mapper class, meaning we are telling the job that here is my mapper class. Okay, if you do not mention here, then it won't figure out what to use as a mapper. Then we say that here is my reducer class, and the partitioner, somebody was asking that what if we have to define, customize how to partition some keys to one reducer and some keys to another. You can create your own partitioner class. You can take a look at the partitioner object. You can define the number of reduce tasks, okay, and also number of input formats. Okay, so this way we can define. All right, or we can go back one more step. I have created, yeah, I have separated out these three things in a separate folder. So this is my reducer, which basically sums up things. This is my mapper, which goes through line by line, cleans up data, and prints error and output. Somebody was saying that what if there is no error? You can actually print error in the code. That's why that file is created. So these are my error messages from my program so that I can debug my code. And then we have driver. Okay, this driver is your entry point. Okay, we define the job config object. Based on that, we define the job object, and then we set the mapper class, we set the reducer class, and we define the path. Here we are saying argument 1, argument 2. Okay, so whatever argument we give to our job will be fed as the input path and output path. Okay, let's try to run it. Let's try to run it. Okay, the steps are here. The steps are: first, take out this repository into your home folder. Okay, let me go here and say already exists. So I'm going to remove my old examples. All right, let me clone it. All right, clone means I have checked out the code from GitHub to my home folder. Okay, what is Git? Git is a code management tool, or we call them SCM, source code management tools. And basically it's a repository where we put code globally. If you have never used GitHub earlier, make sure you use GitHub, because that way it'll build your social profile. Okay, now I go to MR examples folder, which I have checked out recently. This will bring MR example folder, this folder, to your home directory. Okay, then I use ant command and say ant jar. It'll compile, bundle, and put it in a folder. Okay, it says that it has compiled it and kept it in mr.jar. All right, makes sense to you? All right, now we are going to run this in this following way. We're going to run it Hadoop jar build jar slash mr, meaning this is where my code is. Instead of Hadoop streaming dash jar, we are using our own jar and telling which one is our entry point. This is our entry point, and this is our input directory, and this is our output directory. Let's take a look if it runs. Otherwise we might have to fix it a little bit. It says that the output directory exists. Okay, let me put one here and then see. Yeah, it seems to run this time. Okay, so that's how you do the MapReduce in using Java. All right. Question from Saba is it possible to run the same using Hadoop streaming? Meaning these classes, if you can make these classes run by itself locally, then you can do that. Okay. You'll have to write a script, shell script, which contains the Java command which runs the program, and then you can launch. All right. So we are basically doing the word count this time using Java, and that's all. All right. We did the same thing earlier using streaming. All right. Is everybody with me? All right. So run these steps, and there are a couple of exercises in the course. Please follow those, and that should be good enough. There are 4 or 5 exercises. Think about those, and we can discuss it later. All right. So today we have run a couple of examples of Hadoop MapReduce. So we are kind of through with MapReduce. There are 2 or 3 more points to be discussed, and that's all. All right. Great, great. So, so thank you everyone. If you have any question, okay. Sashi's question is, why is it that other languages are not supported when all the mapper needs is an exe? Okay, so basically Hadoop is written in Java. So one way of writing MapReduce is using Java. Second way is running like the system command. If you have used C++, or you have used you must have used ASM command or system command. So the equivalent of a system command in case of Hadoop is streaming. Okay, that makes any program be used as mapper and reducer. Okay, Haricharan's question is, if it is not too much of permission, can you give us permission to read your home directory? Definitely, yeah, that's a good point. Actually, I was thinking to demo last time. I had kind of made my directory read only. Now I have given all of you the permission to read from my folder. If you are on e.cloudxlab, you can actually go to my home directory. Similarly, I am giving you the permission uh, to my home directory in the HDFS. Okay, so both the places you can take a look at my data. All right, thank you, Haricharan. You can take a look at my code. Most of the code I have already shared in the slides, so you don't have to worry about this. Uh, uh, okay. So Maggie's question is, when are you going to post the recordings, please? Just give me a second, Maggie. Let me take a look at. Ideally, it should be there, I think. So if you go into my courses, yes, Sashi, this Git repository is public. Okay, so if you go into The if you go into the this folder here, my courses, so under this all of the recordings should be available. You can see September 3, September 4. Okay, so yesterday and today's I'll have to upload. Actually, I forgot to upload. I thought that somebody will upload, but yeah, so I'll upload it. Okay, it's already uploaded, and we'll just mention it here. All right, just after this session, I'll do that. Thank you, Maggie, reminding me that. Okay, you could have reminded me earlier. I actually totally slipped because generally one of my teammate would update it. Right. So stay connected. Keep asking questions via email. We'll try to rectify your concerns. All right. Thank you very much, and have a great week ahead. All right. Thank you, Deepak. I'm happy that you liked the session. Thank you, Anuja. Thank you, Ajan. Thank you, Bernie. Thank you, Deepak. Thank you, Dhirendra. Thank you, Hank. Thank you, Hari. Thank you, Harsh. Thank you, Jayaprakash. Thank you, Kamal. Thank you, Leeladhar. Thank you, Maggie. Thank you, Mrityunjay. Thank you, Pankaj. Thank you, Rebecca. Please finish these, whatever we did today, run those, and also finish this subjective question. Okay? Finish the subjective questions. All right. Bye bye. Have a great week ahead.